So we are live now. This is the first class of Aeon and how to read Aeon and how to skim through the passages, which passage to read, which passage to skip. This is the first class kind of tutorial for reading Aeon. So the article or the newsletter or the journal I have chose today is the model of catastrophe. The immense. So first of all, while reading an essay or the news journal or the newsletter, whatever you say it, this picture, this title, and the small summary of what the passage is all about, or what the newsletter is all about. Here's the title. Here's a small introduction, very small introduction of what the passage is all about. While reading through the passage or reading through the newsletter, we have to understand at first that what each passage means and which passage and in which passage what is being described in details. We have to understand what the author wants to tell in this passage or in this passage or in this passage, where the author wants to explain one thing with an example. Most of the times the author says something on the first and the second line and then gives an example and explain all the full thing with great details. We have to skim those things. Okay, so let's start it. And so today's title of the newsletter is the model of catastrophe. Catastrophe means hazard, natural disasters, something like that. Okay, so catastrophe means destruction of natural and man-made things, and the model of catastrophe. See, most of us or any of us doesn't could haven't understand what is the meaning of model of catastrophe. Catastrophe means we know earthquakes, tsunamis, and everything, volcanic eruptions, everything. But what can be the model of catastrophe? It is explained in the short introduction here. The immense complexity of the climate makes it impossible to model accurately. Instead, we must use uncertainty to our advantage. See, if we came to know about the meaning of catastrophe, we can see that an event causing great and unusual sudden damage or suffering or a disaster. As I have said, it's a disaster, it's a hazard, anything you can say it. It's a tragedy. It's a tragedy. Okay, so someone or any organization wants to model the catastrophe. Okay, now we can understand that modeling means we are not making a model of how the catastrophe or the place where the catastrophe hit, what damages it caused. We are not making a model or a 3D model of a mm, earthquake prone zone or um, of a zone where earthquake occurred, and then the destructed buildings and everything. We are not doing that. Model of catastrophe closely and logically means that someone wants to predict a catastrophe. Someone wants to have a model so that someone can predict, someone can get an early sign that one catastrophe is going to hit in some place, in some hazardous zone. Okay, this could be the possible meaning of the model of catastrophe. So the immense complexity of the climate. So climate is immensely complex. The author is saying the climate is immensely complex. It's very complex. It makes it it makes it it means the climate makes it impossible to model accurately. So someone can here the author also say that we can predict the catastrophe, but we can't predict accurately because of the complexity of the climate, the complex nature of the climate. Instead, we must use the uncertainty to our advantage. The author is saying that we cannot predict accurately. There are many uncertain things. So, as we can't predict accurately, we should use the uncertainty as our advantage. How we can use the uncertainty as our advantage? I think the author has discussed it in this 4,000 words newsletter. Okay, so let's start. Today's complex climate Today's complex climate models aren't equivalent to reality. So nowadays, the climate models or the process or anything that predicts the climate aren't equivalent or aren't up to the level of the reality, because the author wants to say that the reality is something and the models are predicting something else, or it's not coming close to what it is in the reality. In fact, computer models of the earth are very different to reality, particularly on regional, national and local level. So the author is saying that the computer models that predicts the climate are different from reality, and particularly on the regional level, the national level and the local level. Scales means level, like the same thing. They are the same thing. They don't represent many aspects of the physical processes that we know are important for climate change, which means we can't rely on them to provide us detailed local prediction. So the author is saying that these modern days models, models means computer models. These modern day computer models do not shows or represent the many aspects of the physical processes, many aspects of physical processes of the nature, which we know, as theoretically we know that they will affect or have an effect to climate change, which means we can't rely on them, on these computer models, for detailed local prediction. This is a concern because human induced climate change is all about our understanding of the future. This understanding empowers us. It enables us to make informed decisions by telling about the consequences of our actions. It helps us to consider what the future will be like if we act strongly to reduce the greenhouse gas emissions. If we act one and a half heart only heartedly, we or if we take no actions at all, such information enables us to access the level of investment that we believe worthwhile as individual communities and nations. It enables us to balance the action on nature, action on climate change against other demands on our finances such as health, education, security and culture. Okay, so in this paragraph the author wants to say is that at the first the author wants to say is that nowadays climate models are unreliable, not unreliable, but it doesn't predict accurately to the reality. It in it doesn't shows many aspects or many physical processes that can affect the climate change, that are important for the climate change, or that are that we know theoretically that it will help in climate change in a long run or in a short term run. Okay, so this is a concern because we cannot rely completely on the computer models because they are not accurate on regional, national, local level. Okay, so this is a concern. We can why it is a concern? Because we cannot predict the future correctly. We cannot get we cannot get information about what can happen, what climate changes can happen, what effect can happen, what effects can happen on a region, on a local area, or on a national level or on a regional level. Okay, what that the consequences, what are the phenomena that are causing this climate change. Okay, and what will happen if we don't take any action here here if we don't take any actions, what are the consequences of that. Okay, in this paragraph the author is saying that we cannot rely because this it is inaccurate. It's inaccurate, it's inaccurate in the computer models are inaccurate, and we cannot predict the climate change. We are missing important informations so that we can take informed decisions. We are lacking many informations. Okay, so this is it is in it's very simple. For many of us, these issues are approached through the lens of personal experience and personal cares. We want to know what changes to expect, where to live, where we live, in the place we know, and the regions where we have our roots. The local climate predictions condition to the choices of the societies we make. Okay, so author further explains that this lack of information due to this inaccurate or inefficient climate change computer models, this will affect our personal experiences. Because what if the place I live in or the place you live in could get affected by a catastrophe, or due to climate change, it could be a, it could result in a catastrophe, and that could destroy the place you live in. So if we are informed that on this year or in this range, if this process continues, or if this way of global warming, of this way of um, emission of greenhouse gases continues, in this year or in this range of year, this place will be flooded, this place will have thunderstorm, and it will be destroyed and everything. If we know from now, if we know it from now, we could take steps, we could take informed decisions, we could make decisions, we can shift in other place that is not affected, that or that will not get affected from that catastrophe, or any near catastrophe in the near future, or in a long term. Okay, so the author is saying that this inaccuracy or this inefficiency of the computer models doesn't only affects the experts to predict the near future, or the or what is going to happen to this land in the coming 50 years, or in the coming 10 years, or the coming 2 decades. It doesn't only make a concern to the experts that predicts the who predicts the future, but also the local people who live there. Okay, so where do we get them? Well, nowadays most of the predictions originate from complicated. Uh, so now the author is trying to explain that where do we get the models or the computer models or the predictions are originated from. So now where do we get from all of them? Well, nowadays most of these predictions originate from complicated computer models of the climate system, so called the earth system models. These are called these complicated computer models that helps us to predict a catastrophe, helps us to detect the climate change, what are the adverse effects of the climate change. These are called the earth system models or ESMs. These models are ubiquitous. They are present everywhere in the climate change science. Climate change science. In climate change science, in meteorology, in hydrology, in every logy that is associated with climate change, these earth system models or the ESMs are used. Okay, and for a good reason. Why? The increasing greenhouse gases in the atmosphere are driving the climate system into a never before seen state. Okay, that means the past cannot be a good guide to the future, and the predictions based on simply on historical observation can't be reliable. The information isn't in the observational data, so on. So no amount of processing can extract it. So climate prediction is therefore is about understanding the physical processes and of the climate, not about the data processing. And then the physical processes are involved, everything and the moment of the interaction with the oceans, ice sheet, and everything. Okay, so in this long, big, fat paragraph, the author wants to say that we nowadays or through all these years, our system models helped us to predict any catastrophe or just helped a little bit with all the uncertainties, helped us a little bit in our predictions. The earth system models, these are present everywhere, where in every organization or in every sector that is associated with climate change science. Okay, now the author is saying that the increasing emission of greenhouse gases in the atmosphere, it is leading the atmosphere or leading the earth or leading the environment to such a state that is never seen before. So the author is saying that we cannot predict the future by from the data or from the experiences from the catastrophes of the past. We cannot do it. It's not on the observational data. Prediction of the future solely or the future catastrophes or future climate change solely depends on the our understanding of the physical processes of the climate and not about the data processing that we have, or not about the data, or not and not about the processing of the data that we have collected from the past. Okay, so but there is a problem. The models aren't equivalent to reality. We have seen this problem here also. Okay, so how can it reality make them more detailed and complicated? That raises an important question when the model is implementing only. So what can we do? One option comes, make the models better, make them more detailed and more complicated. That too raises the important question: when is a model sufficiently realistic to predict? But it means that we can make them more detailed so that they can give us more details, and this detailed outcome of the models will make the data complicated. Okay, so a question arises that how much detailing we have to add, or how many updates we have to give to that earth system models ESMs so that it can give us the accurate data, or how much complex we have to make the earth system models or the outcome of the out system models is what I'm saying, art system models, so that it can give us the accurate data. We don't have an answer to this question. Okay, in the scientist, we don't have to read this. Nevertheless, changing the way of our system models, we can provide different and better way of to generate local climate information we seek. Nevertheless, changing the way we use. Now the author is giving another option. We can change the way we use the Earth system models or the ESMs so that it can give accurate and more better data or generate more data, better data to uh, mm, predict for the local climate or the local or the regional scale for the local and the regional scale. Better data and the better prediction that will lead to a better prediction. Okay, so doing so involves embracing uncertainty as a key part of our knowledge of the climate change. So we have to embrace, we have to accept the uncertainty, and we have to use that uncertainty as a part of the knowledge. It involves stepping back and accepting that we want we, what we want is not precise predictions but robust predictions. Even if robustness involves accepting large uncertainties it in what we can make about the future, we have to accept that we don't want to make precise predictions on this date this will happen, on this year this will happen. We don't want to make that kind of prediction. We want to make a robust prediction, a larger prediction or the bigger picture that this could happen if we go on doing like this in all the years coming in the future. Okay, we want the robustness. At least we want to know the region. What can happen, what would not happen, what can happen and what cannot happen. That's another part. That's another question. Okay, so here is a very long thing. We want to skip it because it. I have saw there's a predicting our climate future 2023 11 paragraph summary where the human induced climate change by doing the runs of risk and interpreted downplaying seriousness. No information. We cannot gain any information about the passage, but just robustness. Extra informations are there. We don't want to read this. It's an easy pick holes in your computer models. As the statistician George Box said, all models are wrong, but some are useful. The real question is whether these models are useful, and this depends on the problem you are trying to solve. To see why we need to delve a little into how these models work. Okay, how these models works, we don't want to know this. Okay, so the author further says that it is easy to point out the flaws in the computer models. As the statistician George Box says, all models are wrong, but some are useful. Okay, so all the computer models are wrong in some way. Okay, but they are useful in some ways. How they are useful, that depends on what problem you want to try to you are trying to solve. Okay, so how this CSM models works, we don't want to know it. CSM fantastic. They break up 20 to 100 kilometer long range grid box, dynamic core, anything, everything. Just because they are great research tools doesn't mean they are reliable engines for prediction. Okay, we got it. We got it, and they are not reliable. The author has said it multiple times in the previous paragraph. They are not reliable. Okay, I am not going to go through all this dynamic core and George Box terms before getting to the worth reflecting ocean circulation sea range. We are not going to go through all this. Perhaps I don't want to spell this. Okay, need to be induced models and code called pa- parameterization scheme, parameterization scheme, these models induced. Okay, so I want to just go through this first paragraph. The second and third and second, third, and the fourth paragraph are not of any use. Okay, so but by the dynamical core isn't simulate the Earth's climate system. Let me have some water. Okay, just give me a second. Okay, but the dynamical core isn't enough to stimulate the Earth's climate system. That's because there are many critical processes that we don't fully understand and for which we don't have robust and well-tested mathematical representation. Example, the behavior of tropical and temperate forest. There are also many processes such as clouds, atmospheric conventions, uh, ocean eddies, which take place on a scale that are much smaller than the grid boxes and yet tremendously important for the behavior of climate change. So here are some phenomena, name of some phenomena, and that we don't understand. Okay, behavior of the tropical temperate forest that we don't fully understand. We understand a certain part, but we don't fully excelled about what's the behavior of the tropical and the temperate forest. There are also many processes such as the cloud, this, which are much smaller to fit in the grid boxes, but they are tremendously important for the behavior of the Earth's climate, how the Earth's climate is going to behave, how the Earth's climate is going to change, or it's not going to change. These processes are minute plus important. These are minute but important. Okay, so this process to be induced in the processes if they are able to simulate climate change, but we can't represent what is actually going on because we either it don't know or it's computationally infeasible or both. So these processes need to be included in the models. Okay, the processes we don't fully understand, the processes that are minute but doesn't fit in the grid boxes, these are to be included in the models, but either we don't know what's going on or it's computationally infeasible or the computer models are not capable enough to fuse or to extract information out of these minute or small processes. Okay, clouds, ocean eddies, and many land surface systems are example of this process represented in this way. Okay, this is we do not know. There is no significant disagreement in the climate research community that models have significant flaws. Okay, it's official that models have significant flaws. There are two camps. See, we have to understand which one we have to read. Okay, the paragraph just below these highlighted lines. Okay, the paragraph just below the highlighted lines and these ones. The paragraph just that is starting with a very big font. Okay, so unfortunately, multi-decadal timescales, almost everything can influence almost everything else. Changes in the Arctic sea ice could influence Indian summer monsoon. Changes in the North Atlantic could influence temperature patterns in the Central Africa, and all relevant aspects is awful a lot of things. Okay, so the author is further saying that in the model has certain flaws, very much flaws. The model has certain flaws, but on a multi-decadal system time scale, that we want to predict on multi-decadal time scale, that on this decade this can happen, on the next decade this can happen. On a multi-decadal time scale, almost everything can influence almost everything else. Arctic Circle, changes in the Arctic sea ice could change Indian summer monsoon. Changes in the North Atlantic, rainfall in the North Atlantic could make change, influence or make changes in the temperature patterns in the Central Africa. So, furthermore, today's Earth system models are not close to reality. We have already started. No, we already know it. Okay, in many ways, North America, that this that we don't want to know these things. Okay. For those wanting to study regional consequences, climate change, it's just yapping, unnecessary yapping. Here comes the main thing. There are two camps. There are two camps, like other two poles, the North Pole and South Pole. There are two camps, like in the World War. After the Second World War, the world divided in two camps. One with the Soviet Union, one with the USA. Okay, here also there are two camps. One that takes the perspective of today's model are inadequate to the task we need to make them better. The other takes the view of making them better is of little value until we understand how much better we need to be. Okay, so one set of people believes that these models, today's Earth system models or the computational models, are inadequate to the task we want to use them for. We have to make them better. The second set of the second camp says that making an Earth system model better, it doesn't add any value. It doesn't make any sense until or unless we have the clarity that how much better we want to be, how much better the we want the our system models or the ESMs to be. Okay, and since we have no way of knowing when a computational model would be good enough to make reliable multi-decadal prediction for the local climate, this camp tends to focus on the need of the cleverer ways using both our models and scientific understanding. Okay, and this on second camp says that since we have no understanding or no way of under knowing how much upgrade we have to make to the ESMs for making multi-decadal, for making reliable, to be noted, reliable multi-decadal predictions for the local climate. This camp will focus on cleverer ways of using both these models which have many uncertainties, and our scientific understandings. By mixing and by blending the processes of this data obtaining from these models and our scientific understandings, we can predict, or we can have not reliable but robust prediction about the multi-decadal multi-decadal prediction on the local climate. The first camp will coordinated at summit in Berlin 2023. Earth Visualization Summit engines have blah 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 blah, $15 billion, 10 years. ESM reducing size of the gate boxes roughly to 1 kilometer on each side. Okay, very good. We don't want to go through this everything. All this yapping. Making climate predictions requires models that are close to reality in the way weather forecasts are not. It's a good argument. High resolution may need may indeed make the possible to remove some of the parameterizations. Other for other phenomena such as clouds, increasing level of detail in might enable the models more closely represent our physical understanding and underlying processes These improvements will make the scientists to study additional aspects of the many complex interactions of the climate system. So increasing in the resolution of system models better could be better, or at least tools can tools for in at least additional tools for some types of research. But will it produce a reliable climate change product? The answer is, in my opinion, is no. I won't. It won't. This place is these places are This places me squarely in the opposing camp. The higher resolution may be higher in the models, but with finer grid, but there will be many process missing processes that are known to be important, such as aspects of the atmospheric chemistry and ocean biogeochemistry. Despite step changes in resolution, the models are also need to statistically fit in the parameterization schemes, which represent everything uh, from the land surface effects as vegetations to many processes in the atmosphere, ocean, and cryosphere. Simply put, the models will not be close to the representation. Okay, now in these two paragraphs, the author said that yeah, higher resolution could make make us understand a few details about the atmosphere or of what he has seen. A high resolution camera in the satellites. Okay, we can get a more detailed picture. We can get a few, not all, a few more details from the extraction of the details from the system models or the ESMs. Um, but is this enough to make a reliable prediction? The author says no. This won't, because with finer grids and with high resolution, we can get few more details about the climate and everything, about the land, atmosphere, ocean. We can get a few more good quality pictures, and you can get a few more minute details. Okay, but this won't help us fully to make a reliable prediction. Because why? Because with all these high resolution and finer grids, smaller grids, there will be some missing processes. Some, not some, many missing processes. The processes that involves atmospheric chemistry, ocean biogeochemistry, that we know that are important for climate change, that are important in that will and know that will influence climate change, but that can't be. But these processes cannot be known by increasing the resolution or making the grids finer. Okay, so if our models aren't sufficient close to reality, high resolution isn't. And if has isn't the answer, what's the approach of the other camp? Who are they and what are they calling for? Well, the other camp isn't really coherent group. They compromise miscellaneous collections of academics from variety of these disciplines who see the problems and describe above and are looking for different ways forward. They tend to think about the future by focusing on what could happen rather than what will happen. Okay, so the second camp believes that yeah, there are mistakes or there are faults in the ESMs or the computational models, but we focus on what could happen. What are the possibilities? What are the possibilities that this can happen rather than this will happen? We're 100% sure that this will happen in this place in this time. Rather than this, the second camp focuses on this could happen in this range of year or any year in this range. We are not sure about that, but this could happen because of these activities. The real key is to useful climate surveillance though mm, is that they should always come in packs. Important to recognize it's important to recognize that not anything goes in a storyline approach. That this will happen, after that this will happen, after that this will happen, after that this will happen. We cannot predict that accurately. Okay, it is not a matter of picking a narrative's possibilities out of the thin air. Rather, the changes need to be consistent with our scientific understanding of the processes involved. We need to able and describe the credible way the how different types of change might come about. So long as we have to, as so long as we can do that, storylines provide a route to the exploring the range of future climatic behaviors that we should consider when making societal decisions about climate change. They can be designed to consider specific locations and issues, and they focus on leveraging scientific expertise and understanding rather than computational models. This was a little bit of yapping and the same and repeating of the same concept that we have read before. So the newsletter is at end. Many alternative model versions will be credible as the original model, but might show us different possible paths. There is, however, an alternative way to prove what could happen in the future, which would still utilize the ESMs, rather continually making these models better, chasing the illusionary prospect of the models that sufficiently realistic of a model that's sufficiently realistic to make trustworthy climate focus. We could instead push them respond differently to increase the to increase atmospheric greenhouse gases. Our aim should be diversity of response. We want lots of models together represent just how differently the future could play out at the scale that matters to us. This approach means designing our collection models useful as a whole by using them as a collection rather than focusing on an individual model examining. So the author is saying that don't try to fix an individual or a single model or a single ESM and make it uh, more complex and make it more scientifically realistic or more realistic to the real world and make it more trustworthy to make us to so that we can gain accurate climate for focused forecasts. Okay, we should use lots of models together. We should mm, get the generated results or the extracted data from all the models, compare everything, and then select or then predict the possible future that this could happen, and not saying this will happen, this could happen. That is a real these are very good research tools and blah 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 modern models, and many of these alternative model versions will be credible to making original but might shows us the different paths how climate change will happen, and the furthermore it can happen. Um, okay, so this is everything. Our knowledge is of uncertainty is also a part we know about the climate change. Our knowledge of uncertainty is also a part what we know about, but focusing on high resolution modeling is dangerous, not only because we have to answer the question of when a model is sufficiently realistic, investing in this approach also made also means we don't have the capacity to explore uncertainties, which inevitably encourages overconfidence in the predictions of the models we make. The particular is a particular concern about the ESM are increasingly being used to guide decisions and investments across our societies. Over confidence in model-based predictions, therefore, risks encouraging bad decisions and blah 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 blah. So the author again wants to tell that uncertainty is a part of what we know about the climate change. So the main thing is that the catastrophe model of the catastrophe. The author gave the title of this newsletter as model of the catastrophe. I think, or by reading all these paragraphs and all the paragraphs and all the lines, we can say that the catastrophe here means climate change. Okay, so author again says that don't focus on the high resolution cameras, high resolution modeling, because it will because we don't have the answer, but that how much upgradation of the models will be sufficiently will make the model sufficiently realistic. Okay, investing in the approach also means or going through this approach of making high resolution cameras, making the grid smaller and the final grids. This will also mm, indicate that we don't know how to explore the capacities. We don't have the capacity to explore the uncertainties of the model, the uncertainties that the model gives us. This is a particular concern about the ESMs because ESMs through the data that the ESMs produce, many investments are made across the societies across the world. So overconfidence in model-based prediction. So if we overconfidently mm, make predictions in this through these ESMs solely on these ESMs, by basing solely on these ESMs, will might create risk of encouraging bad decisions. We can make bad decisions, or we can make decisions that seems to be right at that point of time, but in the future, the decisions were came to be wrong. The decisions turned to be wrong. Okay, so it is if we understand the uncertainties well, we could bring our values and bear the risks we are willing to take. Uncertainty, therefore, needs to be at the core adaptation planning, while also being the lens through which we judge the value of climate policy and the energy transition. In my view, climate researchers and modelers wanting to support society should focus on understanding, characterizing, and qualifying the uncertainty, avoid the trap of seeking the climate models that make that make reliable prediction. They may well never exist. So, in the last paragraph, the author is again saying that try to excel, try to understand, try to adapt, try to quantify the uncertainties that the earth system models gives us, and not run behind and focus on making ESM so much capable that it can make reliable prediction. Author is saying that such a model might not exist, might not never exist. Okay, so this was our paragraph or newsletter on the model of catastrophe. Tomorrow we will start another newsletter on another topic or another genre. So, goodbye.